Alright, so we have been going over radiation. Let's recap what we've done so far with radiation. Remember that radiation is when a nucleus of an atom falls apart. Okay, so first thing that we're going to do with this video is talk about how we know if it's going to fall apart. Remember that we always start with hydrogen because it is the simplest atom and it only has one proton in it. Okay, so if I have one proton floating around, that's as simple as I can get. That can't fall apart. So we know that hydrogen 1 is stable. Okay, what we can also do that we've never done before, remember this is my mass right there. This tells me that I have one proton because every hydrogen atom has one proton. We can also write a 1 here to also say that it is, this is my atomic number, which is my number of protons, right? And while that is what this hydrogen is saying, sometimes it's easy to have the number written here, so that, and we'll show you why in a couple of videos, but just so that you know, this one is the mass number, this one is the atomic number. Okay, and so this is stable. When we just have one proton floating around, it is going to be stable. Well, so if we complicate that slightly and we say, okay, I have one proton and I have one neutron, now we don't have one hydrogen anymore because we've added one neutron, and so we now have two hydrogen. Okay, this one is also stable, and hydrogen 1 and hydrogen 2 are isotopes of each other. So they are the same element, both of them have one proton, but this one has an extra neutron in it. Both of these are stable, both of them occur naturally, but it weighs 1 AMU more. We can also have three hydrogen. Okay, this is not stable. Okay, so this one we would expect to start falling apart and shooting out radiation and being radioactive. Alright, moving up the scale then, if I go up to 2 protons, we run into a problem that we didn't have with hydrogen because positive charges repel. Okay, they do not want to be together. They don't like each other. Okay, so they're going to push away from each other. So now we have to have the neutrons. We have to have something to buffer them, to hold them together. And what we find is that the protons, or the neutrons, sorry, do that very, very well. So what we would say is that if we have 2 helium, that is not stable. If we have 3 helium, and helium is always going to have a mass of 2, this is also not stable. Both of those would be radioactive. If I have 4 helium, which is what I drew on the previous slide, this one right here, 4 helium, that would be stable. Okay, because I have the equal protons and neutrons. Okay, I can even go up one more. There we go. And go 5 helium. That would still be stable. But 6 would be too much. It would go unstable again. A quick way for us to tell this is if we go to our periodic table and we look at helium, it will have 2 written up here, and that's our atomic number, right? Which is the number of protons. And then down here it has 4.008 or whatever number it happens to be on the periodic table. This is an average of the isotope's weights. So if we round down, the most common isotope probably will be 4. If we round up, the other stable isotope will be 5. These will be our 2 stable isotopes. So with lithium, we see we have 3 and it is 6.9. Okay, so we round down. 6 is stable. 7 is also stable. We can also tell which is more common. Because this is 6.9, 7 is probably the more common isotope, so we can say that I would have 3 positive charges and 4 neutrons in that one, most likely, that you would find in nature. Alright, so that's how we kind of look to see what is stable, what's not stable. We just use the periodic table, we look at the average atomic mass, and we go from there.